We are looking at how to identify trig ratios. For the lesson, we started with identifying that no matter how big or how small our triangles are, if they have the same slope, they'll always be the same type of triangle. They're similar triangles. So no matter how steep the angle is, meaning that little angle at the bottom, whether it's shallow or not, the rise over run is the same in both triangles. It's always going to be the same. So to simplify this, given any right triangle, if I have a given angle at the bottom here, the rise over run is going to be the same no matter what. This is called the tangent ratio. The tangent of any angle is always going to be the rise over run. This trig ratio, the rise over run, is called tangent. But wait, there's more, because we have 3 total trig ratios. We have sine, cosine, and tangent. So it's not just the rise over run, we can also include the hypotenuse. So there is some verbiage over here that can help you identify the rise over run or the opposite over hypotenuse, things like that. But we have a quick way to remember this. There's a phrase called so, ka, toa. The S represents sine, S-I-N for short, but we call it sine, and that is the opposite, O, over the hypotenuse, H. So that's how we get the O over H, O over H. The cosine is A over H, and that represents the adjacent over the hypotenuse. And the tangent is opposite over adjacent. So O over A. So we have A over H for cosine. We have O over H for sine, O over A for tangent. So ka, toa. So a quick little review here. I'm looking at the sine of A. A is the given angle. So that's where I'm going to mark it. And that tells me the opposite side, which is 4. Then I can look for the hypotenuse from the right angle, which is 5. And lastly, the 3 is the adjacent. So if I'm looking for sine, the sine of something, S-O-H, so I need the opposite, which is 4, over the hypotenuse, which is 5, 4 over 5. And that is our trig ratio for sine of A, sine of A. So again, looking at the second problem, my given angle is B. So I'm starting at this angle here. That'll tell me what is opposite. The right angle tells me the hypotenuse, and that leaves me with the adjacent. So then the cosine, CAH, is telling me to start with the adjacent this time, which is 6, over the hypotenuse, H, which is 10. This can be simplified by 2 to get 3 over 5. That's our final trig ratio for cosine of B. Tan of C, tangent of C, well, that's starting at angle C to tell me the opposite, which is 12. The hypotenuse is 15, leaving me with the adjacent, which is 9. Tangent, toa, so ka, toa, is opposite over adjacent, so opposite is 12. Adjacent is 9, and I can simplify these both by 3 and get 4 over 3 as my trig ratio for tangent of C.